Functional groups in carbon compounds. Till now, we have learnt about the hydrocarbon compounds formed by the chemical combination of the elements carbon and hydrogen. Now, let us learn about many more types of carbon compounds formed by formation of bonds by carbon with other elements such as halogens, oxygen, nitrogen, and sulfur. The atoms of these elements substitute one or more hydrogen atoms in the hydrocarbon chain, and thereby the tetravalency of carbon is satisfied. The atom of the element which is substitute for hydrogen is referred to as a heteroatom. Sometimes these heteroatoms are not alone but exist in the form of certain groups of atoms. Due to these heteroatoms or the group of atoms containing heteroatoms, the compound acquires specific chemical properties irrespective of the length and the nature of the carbon chain in that compound. Therefore, these heteroatoms or the groups of atoms containing heteroatoms are called functional groups. Come, let us now study about some functional groups present in the carbon compounds. First is the halogen atom. Halogen atom comprises the elements chlorine, bromine, and iodine. Halogen is named as halo, while chlorine is named as chloro, bromine is named as bromo, and iodine is named as iodo. The structural formula of halogen is X, while that of chlorine is Cl, bromine is Br, and iodine is I. Alcohol, aldehyde, ketone, carboxylic acid, ether, and ester are the different functional groups of oxygen. The structural formula and condensed structural formula of alcohol is OH. The structural formula and condensed structural formula of aldehyde is CHO. The structural formula and condensed structural formula of ketone is CO. The structural formula and condensed structural formula of carboxylic acid is COOH. The structural formula and condensed structural formula of ether is O. The structural formula and condensed structural formula of ester is COO. The functional group of nitrogen is amine. The structural formula and condensed structural formula of amine is NH2. Here, the free valency of the functional group is denoted by a short line. The functional group taking place of hydrogen atom joins to the carbon chain with this valency. The carbon-carbon double bond and triple bonds are also recognized as functional groups as the respective compounds get specific chemical properties due to them. Come, let us now understand what is meant by the homologous series. Homologous series. We have seen that carbon atoms combine with each other forming chains of different lengths. We have also seen that a functional group can take place of an hydrogen atom on these chains. Thus, with the same functional group but different lengths of carbon chains, a large number of compounds are formed. For example, methyl alcohol, CH3OH, ethyl alcohol, CH3CH2OH, propyl alcohol, CH3CH2CH2OH, and butyl alcohol, CH3CH2CH2CH2OH, are the various compounds formed from the functional group alcohol. Although the length of the carbon chains is different, the functional group present in them is the same, due to which their chemical properties are very much similar. The series of compounds formed by joining the same functional group in the place of a particular hydrogen atom on the chains having sequentially increasing length is called homologous series. In accordance with the functional group, there are different homologous series. For example, homologous series of alcohols, homologous series of carboxylic acids, homologous series of aldehydes, etc. To learn about the characteristics of the homologous series, let us consider the initial part of the homologous series of alkanes, alkenes, and alcohols. Let us start with alkanes. The molecular formula and condensed structural formula of methane is CH4. The number of carbon atom in methane is 1 and the number of CH2 unit is 1. The boiling point of methane is minus 162 degrees Celsius. The molecular formula of ethane is C2H6 and its condensed structural formula is CH3CH3. The number of carbon atoms in the structural formula is 2. The number of CH2 units is 2 and its boiling point is minus 88.5 degrees Celsius. The molecular formula of propane is C3H8. Its condensed structural formula is CH3CH2CH3. The number of carbon atoms is 3. The number of CH2 units is 3 and its boiling point is minus 42 degrees Celsius. Then, butane. Molecular formula C4H10. Its condensed structural formula is CH3CH2CH2CH3. The number of carbon atoms is 4. The number of CH2 units is 4 and its boiling point is 0 degrees Celsius. The next compound is pentane. Molecular formula C5H12. Its condensed structural formula is CH3CH2CH2CH2CH3. The number of carbon atoms is 5. The number of CH2 units is 5 and its boiling point is 36 degrees Celsius. Hexane. Molecular formula C6H14. Its condensed structural formula is CH3, CH2, 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 CH3. The number of carbon atoms is 6. The number of CH2 units is 6 and its boiling point is 69 degrees Celsius. The first two members of the homologous series of alkanes, that is methane and ethane. Similarly, the other consecutive members, that is ethane and propane, propane and butane, butane and pentane and hexane differ by one CH2 unit. From this, we understand that the family of alkanes is a homologous series and have the general formula CnH2n+2. In this general formula, the value of N of the first member of alkane series is 1. When the value of N is 8, the molecular formula C8H2 that is C8H18 of the 8th member is obtained. When the value of N is 12, the molecular formula C12H2 that is C12H26 of the 12th member is obtained. Now let us study about the homologous series of alcohols. The first compound of the alcohol family is methanol. The molecular formula of methanol is CH4O. Its condensed structural formula is CH3OH. The number of carbon atom is 1. The number of CH2 unit is 1 and its boiling point is 63 degrees Celsius. The second compound is ethanol. The molecular formula of ethanol is C2H6O. Its condensed structural formula is CH3 CH2OH. The number of carbon atoms is 2, the number of CH2 units is 2, and its boiling point is 78 degrees Celsius. The third compound is propanol. The molecular formula of propanol is C3H8O. Its condensed structural formula is CH3CH2CH2OH. The number of atoms is 3, the number of CH2 units is 3, and its boiling point is 97 degrees Celsius. The fourth compound is butanol. The molecular formula of butanol is C4H10O. Its condensed structural formula is CH3CH2CH2CH2OH. The number of carbon atoms is 4. The number of CH2 units is 4, and its boiling point is 118 degrees Celsius. From this, we understand that the general formula of alcohols is CnH2n+1OH. On observing the formula of the third and fourth member of the homologous series of alcohols, we find that the fourth member contains one extra methylene unit than the third. Now let us study about the homologous series of alkenes. Ethene is the first member of the homologous series of alkenes. The molecular formula of ethene is C2H4, and its condensed structural formula is H2C double bond CH2. The number of carbon atoms in ethene is 2, the number of CH2 unit is 0, and its boiling point is minus 102 degrees Celsius. The second member is propane. Molecular formula C3H6. Condensed structural formula CH3CH double bond CH2. The number of carbon atoms is 3, number of CH2 is 1, and its boiling point is minus 48 degrees Celsius. Next, 1-butene. The molecular formula of 1-butene is C4H8. Its condensed structural formula is CH3CH2CH double bond CH2. The number of carbon atoms is 4. The number of CH2 units is 2, and its boiling point is minus 6.5 degrees Celsius. The next member is 1-pentene. The molecular formula of 1-pentene is C5H10. Its condensed structural formula is CH3CH2CH2CH double bond CH2. The number of carbon atoms is 5. The number of CH2 units is 3, and its boiling point is 30 degrees Celsius. On observing the second and third member of the homologous series of alkenes, we find that the formula of the second member contains one methylene unit less than the third member. The molecular formulae of the members of the homologous series of alkenes can be represented by the general formula CnH2n. On carefully observing the table, we find that there is a relationship between the number of carbon atoms and hydrogen atoms in the molecular formulae. The number of hydrogen atoms is double the number of carbon atoms. This means that when the number of carbon atoms in the molecular formula is n, the number of hydrogen atoms is 2n. When the value of n is 2, the molecular formula of the first member C2H2 that is C2H4 is obtained. When the value of n is 3, the molecular formula of the second member C3H2 that is C3H6 is obtained. Now let us write down the molecular formulae for the first, second and third members of the homologous series of alkynes by using the values 2, 3, 4 for N in the general formula. The homologous series of alkynes have the general formula CnH2n-2. When the value of N is 2, the molecular formula of the first member C2H2 that is C2H2 is obtained. When the value of N is 3, the molecular formula of the second member C3H2 that is C3H4 is obtained. When the value of N is 4, the molecular formula of the third member C4H2 that is C4H6 is obtained. Come, let us note down the structural formulae of the first 4 members of the various homologous series formed by making use of different functional groups. Methyl chloride, that is CH3Cl. Ethyl chloride, that is CH3CH2Cl. Propyl chloride, CH3CH2CH2Cl. And butyl chloride, CH3CH2CH2CH2Cl constitute the homologous series of chlorine. Formaldehyde, that is HCHO. Acetaldehyde, that is CH3CHO. Propionaldehyde, that is CH3CH2CHO. And butyraldehyde, that is CH3CH2CH2CHO, constitute the homologous series of aldehydes. Acetone, CH3COCH3. Ethyl methyl ketone, CH3COCH2CH3. Methyl propyl ketone, CH3COCH2CH2CH3. And methyl butyl ketone, CH3COCH2CH2CH2CH3, constitute the homologous series of ketones. Formic acid, that is HCOOH. Acetic acid, that is CH3COOH. Propanoic acid, that is CH3CH2COOH. And butyric acid, that is CH3CH2CH2COOH, constitute the homologous series of carboxylic acids. Methylamine, that is CH3NH2. Ethylamine, that is CH3CH2NH2. Propylamine, that is CH3CH2CH2NH2. And butylamine, that is CH3CH2CH2CH2NH2, constitute the homologous series of amines. We have seen that while going from one member to the next in any homologous series in the increasing order of the length of the carbon chains, one methylene unit, that is CH2, gets added. Therefore, while going from one member to the next in any homologous series, there is increase in their molecular mass by 14U. For example, the molecular mass of methane is 16, while the molecular mass of ethane is 30. Similarly, there is gradation in the boiling points, which shows that boiling point is one of the physical properties of a compound. Generally, while going from one member to the next in any homologous series, the physical properties go on changing in one direction, which shows that there is gradation in the physical properties. From these different examples, we understand some of the characteristics of the homologous series. While going from one member to the next in a homologous series, one methylene, that is CH2 unit, gets added. Molecular mass increases by 14U. Number of carbon atoms increases by 1. Chemical properties of members of a homologous series show similarity. For example, all alkenes undergo addition reaction with hydrogen. That is, ethene, propene and butene undergo addition reaction with hydrogen to form ethane, propane and butane respectively. All members of a homologous series can be represented by the same general molecular formula. Come, now let us learn about the nomenclature of carbon compounds.